In this video, we're going to talk about section 5.3, integrating an exponential function. Let's talk about our rules for integrating exponential functions first. So the basic form looks like this. And the general form that includes the chain rule in it looks like that. So we'll go ahead and use the general rule. We may be combining it with some other rules because as we talked about earlier, we have a rule that tells us if we have a sum or difference of two functions that we're integrating with respect to x, that we can split that up into separate intervals like so. So let's go ahead and look at number 1 from section 5.3. It says the integral of 7e to the 7x dx. 7 is the derivative of 7x. If I do u substitution here, this is e to the 7x. 7 dx is e to the u du. Will be e to the u plus c, so that's e to the 7x plus c. Go ahead and look at number 3 now. And this is integral of -4 e to the x plus x squared dx will be a -4 e to the x dx plus the integral of x squared dx will be a -4 integral of e to the x dx plus integral of x squared dx will be a -4 e to the x. That's our general rule that we just talked about. Our basic rule we just talked about. And this is going to be x to the 2 plus 1 over 2 plus 1. That's our basic power rule, plus c, be a -4 e to the x plus 1/3 x cubed plus c. Let's go ahead and look at number 5. Number 5 says integral of e to the 5x minus 3 dx. Let's use our u substitution here and say u is 5x minus 3. Du dx is going to be 5, which makes du equal to 5 dx. It means that I want to multiply by 5 on the inside and 1/5 on the outside. It's going to be 1/5 integral of e to the u du, be 1/5 of e to the u plus c is 1/5 e to the 5x minus 3 plus c. Let's look now at number 9. I'm sorry, number 7. Number 7 is the integral of 9x e to the -2x squared dx. I'll rearrange a little bit. Pull the 9 out, e to the -2x squared. I'll leave the x dx off to the side here. I'm going to need a constant multiplier, but it's not going to be 9. So u is equal to -2x squared. Du dx is going to be 4x. So du is going to be a negative 4x dx. Let's go ahead and multiply by that negative 4 on the inside and a negative 1/4 on the outside. Gives me negative 9/4 integral of e to the u du is negative 9/4 e to the u plus c is negative 9/4 e to the negative 2x squared plus c. I think you're starting to see why mathematicians like this function of e to the something. It really is pretty easy to differentiate. It's pretty easy to integrate. So let's go ahead and look at number 9. Integral of 5x squared e to the x cubed dx. So I'm going to take the 5 outside and make e to the x cubed here, and I've got an x squared dx. I'm going to find what my du is. That's 3x squared dx. So I need the 3, just off by a constant multiplier. So 3, and then divide by 3 out there. So that gives me 5/3 integral e to the u du is 5/3 e to the u plus c. It's 5/3 e to the x cubed plus c. One last problem for this section be number 11. We have the integral of 2x plus 1 e to the x squared plus x dx. U is equal to x squared plus 1. Du dx is x squared plus x here for my u is my exponent. Du is 2x plus 1. Du dx is 2x plus 1. Du is 2x plus 1 dx. That's what I was trying to say. So e to the x squared plus x, 2x plus 1 dx is e to the u du. It's just going to be e to the u plus c is e to the x squared plus x plus c. All right, that's it for this video. We'll come back next time and talk about the log rule for integration. So logs and exponentials are inverses of one another. We talk about their rules at the same time here. And we just did exponential integration. We're going to do logarithmic integration next. So see you for the next video.